Hi, my name's David Silver. I am the lead instructor for the self-driving car Nanodegree program.
And I'm Anthony Navarro. I'm the product lead for the self-driving car Nanodegree program. And welcome to your first day of the program.
Yeah, we are really excited to have you in class. It's a great program and it's a lot of fun to get started with. And we just wanted to welcome you on your first day by running you through what the classroom looks like and some of the tools that are available and some of the resources that Udacity provides to help you make your way through the program. And then we'd love to answer any questions that you have. So we can get started here in the actual classroom. So if you go to classroom.udacity.com, that should route you pretty quickly to the self-driving car Nanodegree classroom. And you'll see on my screen here that I'm actually enrolled in all three terms of the Nanodegree program. Right now, you're probably just enrolled in this first term, computer vision and deep learning. Each term is about 3 months, and it consists of a number of lessons on different topics. So the very first lesson here is a welcome from Sebastian Thrun. Have you met Sebastian?
I have met Sebastian.
Great guy.
Just saw him down there, down in the parking lot today.
Sebastian is kind of a legend in the autonomous vehicle world. He's also the founder of Udacity, founder of the Google self-driving car project, winner of the DARPA Grand Challenge, and he's been kind of the guiding force behind the Udacity self-driving car Nanodegree program. So he's here to welcome you into the classroom. And then we get started on a quick lesson on finding lane lines on the road. And this is just a nice, fun introduction to the self-driving car program. Anthony, you were a student before you were the product lead here, so you probably did this project as a student, right?
I did. I was actually a student in the October cohort, the first cohort that Udacity had, and this is a great project to kind of get your feet wet. For me, it had been a little while since I'd done like computer vision and things like that. And so it was great to dive back in, learn about the different types of transforms that you use, and just get back used to coding in a classroom environment. So it's a great project to get your feet wet on.
Yeah, and you don't even have to have any computer vision background in order to start the program and do the project. We just ask that you have kind of intermediate level programming ability and then some basic calculus and linear algebra and statistics. And then we teach you all the computer vision that you need in order to do the project.
Yeah. Next, we have our career services. The self-driving car Nanodegree program is a job-ready Nanodegree. So when you finish the entire program, we're hoping to put you in front of our employers and get you a job. And there's a lot of employers looking for skills in this area right now. And so we have a whole careers team to help you, prep for that, review your resumes, review your LinkedIns, go through your GitHubs. And this is where all your career services live. And it's really great to utilize that service if you're interested in a job in this area.
Yeah, so this is kind of an introductory lesson about the career services we have, and then you'll actually see over here on the left, there's this extracurriculars tab that has some more specific lessons about job searching and networking. That may not be something that interests you depending on where you're at in your career right now, but if that's something that would be helpful if you're looking to get a new job in the autonomous vehicle industry, we encourage you to check out those extracurricular lessons. So after kind of that introductory period where we cover kind of welcoming you to the program and a quick introduction to computer vision, we dive into the first real meaty module, which is deep learning. Deep learning is all about neural networks, which are an exciting and really new part of the machine learning space where you train computers to learn how to do tasks from data. And so we have a number of lessons kind of starting from the beginning, introducing you to neural networks. We have a lesson called MiniFlow. Did you do MiniFlow as a student?
I did do MiniFlow. MiniFlow is great because, while TensorFlow abstracts a lot of things from you, MiniFlow is kind of going back and learning why things work. And so you're going from scratch doing this.
Yeah, MiniFlow is like a little made-up, almost toy kind of library we put together that we walk you through building for training neural networks. In reality, when you get onto the job and you're training neural networks, you're more likely to use an open source library like TensorFlow, which is the one we use in the course, but there are others. But before we actually get to those kind of big open source libraries, we wanted to walk you through just a little bit of how these open source libraries work. And so MiniFlow does that. And after MiniFlow, we dive into to what you might actually use on the job, which could be TensorFlow, which is Google's library for deep learning. And then you'll see there are lessons on deep neural networks. So this is taking layer upon layer of these networks and stacking them up so you have this really big network that can learn a lot of different things and store a lot of intelligence inside of it. Convolutional neural networks, which are how neural networks process images. So you feed an image into a convolutional neural network, and the CNN, as it's sometimes called, can help you figure out what's going on in that image. And we'll teach you a little bit about that. And then we get to the second project of the program. So the first project was a basic lane finding project. This is a bit more of a challenge. It's the traffic sign classifier. Do you remember doing the traffic sign classifier?
I do. It was a great project. One thing I will kind of give some advice to students for is that the first project is more relatively simple, I would say, or it's at least easier compared to the second project. So if you spend a few hours on the first project, great, but definitely dive into the material for the second project. You don't want to fall behind, and it does take some time to train your neural network, get used to the idea of how neural networks work and training a system, running it through inferencing and all that. So best piece of advice I have is to start project 2 early and make sure you stay on track with it.
Yeah, one of the really interesting things we've discovered over the course of running the Nanodegree program is one of the biggest indicators of whether a student will wind up completing the first term is simply whether they get over the hump of this traffic sign classifier project. And so we really, really encourage you to focus and try and get through this project, because if you make it through this project, you're really likely, at least according to all the data we've seen so far, to successfully complete the entire term. So it's an important one.
It is.
Then we have lessons on other deep learning libraries, so Keras, which is a little bit higher level or a little bit maybe easier to work with even than TensorFlow. So that's another library you can use for deep learning. We get into a fairly advanced topic called transfer learning. What transfer learning is taking neural networks that have been trained by other people, maybe academic experts or people at other companies, or even networks you've trained yourself for other purposes, and transferring the knowledge that's stored in that network to a different problem. So maybe you train a network to identify dogs, and then you can transfer some of that knowledge to train another network that identifies cats, say. So that's a pretty exciting and advanced topic in deep learning, and one that's really great to have when you go to interviews. And after that, we get to the third project, which a lot of people say is kind of the highlight of this term of the Nanodegree program, which is behavioral cloning. You want to talk a little bit about your experience with behavioral cloning?
Sure. Behavioral cloning was, like David said, it was my favorite project of term 1. It did take a lot of work. It's not exactly like the traffic sign classifier where you get it working and it works okay. Well, this one, if it works okay, that might mean your car's in the ditch. So you really have to get it, it takes some time to get it working and to practice and to try out your different models. I also got to have a great experience kind of applying this in the real world as part of the Udacity self-driving car team, or the race team that we did, where we actually got to apply a deep neural network to the Kia Soul from Polysync and make it around a track autonomously. So it was the same kind of problem using a single camera to do and a deep learning model to actuate the vehicle and control the vehicle. And so to me, this was it's still one of the best experiences. This is a great project to do, and it will take some time, but I know myself, once I completed it and that car made it around the lap, I was just jumping up and down and screaming, and it was exciting.
So yeah, it's a really fun project, particularly once you get your car driving really, really well around the track. The object of the project is to train a car in a simulator. So this is an image of the simulator to drive like a human, and in this case, the human is you. You get to drive the car around the track like it's a video game, and then, like Anthony was saying, you record that data and use that to train the neural network to drive the car autonomously around the track. And this is, in fact, how a lot of startups in Silicon Valley and in other places in the world are trying to get cars to drive themselves, by actually just mirroring how humans drive. So that's the conclusion of what we think of as the deep learning module. And at this point, you'll enter the final module of term 1, which is computer vision. So we did a kind of basic computer vision lesson at the very beginning, kind of just to get started for fun. But now we're going to return to computer vision a little bit more aggressively. So we'll start with an advanced lane finding project. So you did kind of basic lane finding at the beginning of the term. In advanced lane finding, you're going to deal with lane finding on highways that have, say, shadows like you can see here, or bridges with different types of pavement. And you'll use a library called OpenCV, which is kind of the standard library for computer vision.
And it's, again, a really great project to go from the beginning one where you do the basic lane finding to the advanced one. Basic lane finding, you've got kind of straight lines that aren't really conformed to the lanes, and you're just really like, bare minimum, here's where the lines would be. Whereas this project, you're actually outlining, here's the whole drivable area in my lane, and you're conforming to curves. And I've seen some really great student projects come out of it. So, some things people have done have gone above and beyond, and just some of the student submissions we saw early on were just ridiculous. Like, it's really great to see you do that. If you go above and beyond, that's something you can then go and take to an employer and show why you did. If somebody else came with the Udacity Nanodegree, what sets you apart from them?
Yeah, it's a really great portfolio project. You get this really nice video of how you're detecting lane lines on the road, just like you would see in a super advanced driver assistance system.
Yep.
The next few lessons are about other types of machine learning beyond just deep learning. We talk about kind of the introduction to machine learning, kind of how machine learning works, in particular how Sebastian used it on Stanley, which was his car, that's Stanley right there, that won the DARPA Grand Challenge.
Have you ever seen Stanley in person?
It's at the Smithsonian, I think, and I have not seen it. Have you seen it?
It is. I have. I was able to go to it's weird, it's in the time and space area of the, I think, Flight Museum or something. One of the Smithsonian, it doesn't seem like it belongs there, but yeah, it's in the time and space for navigation, and I've got a few pictures of getting to see Stanley.
Cool, I should go check it out. Then we'll move on to support vector machines, which are a specific type of machine learning tool. In some ways, kind of similar in input and output to a neural network, but they work a lot differently on the inside. Decision trees, another type of machine learning tool. And then you can combine a lot of these different machine learning tools along with what you have learned in the rest of the computer vision module to complete the final project of term 1, which is vehicle detection and tracking.
Yeah, and again, same with that one. I've seen some people do, instead of the 2D bounding boxes, 3D bounding boxes around them. But again, it's really cool to see the code that you put down then get implemented in this video and actually be able to drive a car, be able to stay in a lane, be able to identify cars around you. We definitely teach by application, and it's very exciting, the portfolio projects you get out of this program.
Yeah, they're really terrific. And you can see I'm 7 months past due here, so don't be like me. Submit your projects on time. If you don't, actually, you get an extension at the end of the Nanodegree program to make sure that you can submit on time, but then eventually we'll unenroll you from the program. Not because we're trying to be mean, but more just we're trying to make sure you continue on a steady cadence, and we don't necessarily want folks who wind up kind of stuck in one place for a long time.
So all the projects have due dates on them, do I have to finish my project by that due date?
Yeah, great question. So the due dates are kind of soft suggested dates, and you'll see them in the classroom next to each project. The hard deadline is that you have to have completed all your projects by the end of the term in order to move on with your cohort. As I mentioned, if you don't finish by the end of the term, there's an extension, but eventually you'll be unenrolled from the program if you don't finish on time. So try and get your projects in early. If you want to stay on rhythm, which we recommend, submit them by the dates we suggest in the classroom, and make sure that you've got all of your projects submitted by the deadline at the end of term 1.
What happens if I fail a project the first time, or if I don't pass the project rubric the first time I submit it?
Great question. You can submit your projects as many times as you need in order to pass the project. One of the really neat things about Udacity is each of these projects you submit will be reviewed by an actual human who will look through your code. Typically these are people who review a lot of projects, so they've seen a lot of different student submissions, and they have a really good sense of where things might go wrong and what things you can do to improve the code. And in general, we hear from students that they get really impressive project reviews, and if something's wrong, you'll get as many chances as you need to fix it and resubmit.
Great. So we've got a student asking about when they finish the first and second term, they want to do the third term, but they're not going to have time right away to do the third term. Can they hold their position and join a future cohort for the third term?
Yeah, so we encourage you to go through the program with your cohort, and the entire program is about 9 months of content, and with some breaks it takes a little bit closer to 11 months to finish all 3 terms. But you can take breaks between terms if you need them. You can just let us know that you'd like to pick up later, and we'll work with you on that.
Great. So we're going through some of the questions now. So if you have questions, feel free to add them to the YouTube channel, and I'm also going through and looking at them on the pre-submitted questions. So we've got a question here from Spencer from California. How many years away are we from a commercial level 4 self-driving car?
Yeah, I'll let you tackle that one, and then I'll throw in my thoughts at the end.
So my thoughts are we're a little, it's a fuzzy piece because a lot of these companies, what they're doing is behind the scenes. They don't talk about their progress completely. But then there's also not only the technological piece, but there's the regulatory piece. Now, we did have a big win yesterday with the House, I think, voting to allow self-driving cars, that states can't put like these laws against them to slow their expansion. So that's really great here in the US. But I would say it's hard. I think we're closer than maybe we think we are, but then maybe we're much further than anybody thinks. So we'll put it on record. I'd say maybe 4 or 5 years.
4 or 5 years, all right. I usually say that it's more a question of where than when. So there are self-driving cars out on the road today in a few different cities. In Pittsburgh, Uber is picking up passengers in actual self-driving cars. There are trials going on with Google in Arizona and a few other cities. Yep. A couple of companies, Delphi and Nutonomy, are operating self-driving vehicles in Singapore, and they've talked about expanding those trials to other areas. There are some self-driving shuttle buses in different cities. But you'll notice these are like very narrow, geo-fenced areas, downtown cores, often because mapping the areas is really critical to the operation of the self-driving vehicle, and that mapping is really expensive unless you have a really dense area with lots of people traveling around. And so the question is, how quickly can these kind of dense areas where self-driving cars are operating now expand so that you'll see them in more and more places and more people have access to them. And we'll see that expand over time. It'll take a number of years probably till we get to kind of the outer suburbs of big metropolitan areas, and in foreign countries it might take even longer. Yeah. But if you really want to get in a self-driving car and you buy an airplane ticket to the right city, you can do it today.
Yeah, and I think that if you do have these like geo-restricted areas or constrained areas, then you will see them sooner. If you're looking for general mass public, I think it's like David was saying, it's a little further out than that.
Yeah, that's a good point.
Richard from Denver. All right, Denver. I'm from Colorado, so down for that. I understand term 1 is mostly machine learning. What things do you think I can do with this outside of self-driving cars? I work as a data analyst, and we do a lot of modeling.
Yeah. So Anthony I think has a bunch of experience for applying deep learning to different nanodegrees that you work with at Udacity. I tend to focus mostly just on cars, but I do know that data scientists are increasingly using deep learning to solve data problems and build models in all sorts of different areas. Google Translate, as I understand it, has become very deep learning heavy for translating languages. And a lot of things like Google image search, facial recognition technology is moving. Images work really well with deep neural networks, so things are moving in that direction. What things do you work on in other programs?
Yeah, so I would say like what we focus on here is like the convolutional neural networks, and where those really shine are in things like images. If you wanted to do something more like natural language processing, that's usually more of a recurrent neural network, and we don't touch on that in this topic as much. But you're still getting the idea of what deep learning is, how to apply it, how to solve problems with it. And so the skills you learn here are going to be kind of the core skills you could take to a different area, even as diverse as finance. Tons of machine learning going on in finance right now. Everybody wants to know how stock market trends, things like that, all these different ways to analyze non-apparent data or non-apparent patterns. So especially if you're a data analyst, there's a ton you can do. You can, when we get into like even the end-to-end neural network that we have, where we're taking a camera and controlling the car with that, there's recurrent neural networks and other machine learning techniques to make like a bipedal robot walk, do navigation, do manipulation, pick and place. So I think Amazon had a challenge recently where they were doing a pick and place challenge with the robotic arm, and they're using deep learning for that. So what you'd want to do with, I guess, term one is mainly, I wouldn't say it's necessarily machine learning focused, I would say it's perception focused. So when we address perception in ways of machine learning and computer vision. So again, the core skills you get out of that are going to be applicable of many areas. The hardcore, I guess, focus of it, though, is the perception piece. Flint from Singapore. I'm aiming to get a summer internship at Newtonomy. In order to stand out, should I focus on more advanced deep learning or spend time learning some more traditional machine learning? I have completed DL&D and have a fairly poor background on machine learning.
So I think the answer to both of those, I guess, would be yes. It's a little hard to say, which one you might want to spend your marginal hour on, because they're both really valuable. I suspect that if you have minimal background in core machine learning, you might get a lot of bang for your buck in some of the core machine learning topics we touch on in term one, things like support vector machines and decision trees. A lot of those tools are still useful, and they have a lot of principles involved, particularly around how to work with data that maybe would augment the knowledge you already have. In term 3 of the Nanodegree program, we have an advanced deep learning elective that you can take, which deals with semantic segmentation. That's like how you actually paint each pixel a different color based on whether it's part of the road or another vehicle or a pedestrian or the sky. And that's kind of the frontier of deep learning, at least for self-driving cars. So if you're really excited about that, stick with us till term 3. But I think you probably can't go wrong either way, looking more into deep learning or going back and getting some foundations of machine learning.
Yeah. Marlos has a question about the instructions to set up the environment for all terms. You're working in Ubuntu, and is that okay? Actually, Ubuntu is my preferred environment. You can do the Nanodegree on a Mac or in Windows. I prefer Ubuntu because then I don't have to try to make anything work in a different environment. I can also get my GPU running. And then as we get farther into the course, you can ROS actually only works in Ubuntu. So for me, that's my preferred environment too. And so I would recommend that. Linux does sometimes take some finagling to make work. I know Project 2 took me a little while because I had to get my GPU in my computer working right. But I think it was worth it in the end.
Yeah, I think one of the things you'll see actually, so I've had this page sitting up on my browser, but I haven't really talked about it. We have forums in the Self-Driving Car Nanodegree program, and these forums are places where students can come and post questions, a little bit like popular Q&A sites you might see just generally on the web, maybe Stack Overflow, and there are different categories. So when you log into discussions.udacity.com, you should see categories here for term 1, term 2, term 3. And if you look in each of these categories, there'll be all sorts of different questions, and some of them will be related to how to set up your network or set up your environment. You can search for questions. How do I set up my development environment in Windows? And you'll see questions about how to install different things in Windows. Similarly, we have a pretty robust Slack community that you'll get invited to as the Nanodegree starts. It's at carnd.slack.com, but you have to be invited. It's a student-only, invitation-only community. And there are channels in the Slack community related to each of the projects and each of the topics in the Nanodegree. And so if you have issues, that's a great place to go ask questions about how to get your environment set up.
Yeah, so we've got a question about, will there be a project where we'll try to use Google Maps to find the best path from one location to another location using A* or something similar? We're not using Google Maps, but we do have a localization module in term 2, and David can talk to that a little bit.
Yeah, great question about finding a route between two locations using A*. You might have taken Udacity's free AI for Robotics course that touches on A-star. And both in localization and in our path planning module at the beginning of term 3, we will cover how to localize where you are in the world. So if you remember what a particle filter is from AI for Robotics, and you do not have to have taken that free class in order to do the Nanodegree program. In fact, we will kind of start off each of those modules, localization and path planning, with the appropriate material from AI for Robotics so that everyone's on the same page. But if you've taken that free course from Udacity, you'll remember how to use a particle filter to figure out where you are in the world. That's what we'll cover in localization. And then in the path planning module at the beginning of term 3, we'll cover how to route from one location to another using A-star and a more advanced algorithm called hybrid A-star, which is kind of like A-star but with curves, as well as a number of other path planning techniques like using finite state machines and using polynomial fitting to build trajectories on the road. So that's a really exciting and fun module.
Nice. Vijay from Boulder, Colorado. More Colorado people, I like it. Would future revisions of self-driving cars have the ability to choose if it comes to such a situation to save the pedestrian's life over the driver's life? This is a very, I guess, common question. Yeah, I don't know if you want to take this one or...
Sure. Yeah, I mean, this is kind of in the broader category of questions that are sometimes called trolley problem questions. There's this famous philosophy problem. It actually has nothing to do with self-driving cars, but just if you had to send a trolley down one track or another and it would kill 2 people one way and 3 people another way, what would you do? And there are versions of that for self-driving cars. One is like, would you kill the driver or pedestrian? I think it's important not to get too hung up on these philosophy questions. They're kind of interesting to bat around and think about, but the reality is about 1 million people in the world every year are killed in automobile accidents, and the vast majority of those accidents are caused by humans. And so anything we can do to make self-driving cars safer than human drivers is going to be a huge win for the world. And so I think that's really the thing to focus on is how do we make the roads more safe and help keep people alive. To the specific question of making choices about who to kill and who not to kill, I don't think a car would necessarily think about it in those terms, but what a car will think about is a cost function. So when we get to path planning in term 3, you'll learn a lot about how to put together cost functions, and cost functions can have many elements. Simply changing lanes can add a cost. Going faster or slower than the speed limit can add a cost. Putting yourself closer to other cars on the road can add cost. And essentially what the car is trying to do all the time is figure out what is the lowest cost action for me to take right now. And so that's kind of how a car would think about it.
Great. Nick from Hong Kong. Do I need to buy a computer with a GPU card first? You don't. We do give you credits for AWS, Amazon's Web Services, so you can do your GPU programming on there. I liked to have things locally so that I didn't have to upload and do all that, but we do give you an option if you don't have a GPU on your computer. Habibi from Tokyo. I read in the description somewhere on a website that there will be an implementation using a real car. Are we telling students that? Yes, you actually do get to put your code on the real car. It's our final project at the end of term 3. Can you talk about how that's going to work?
Yeah. So we view the possibility of putting your code on the actual Udacity self-driving car is one of these things we call an only at Udacity experience. This is something that's really, really hard to come by anywhere else. And we think it's a really exciting capstone to the whole Nanodegree program. So over the course of these 9 months, you learn about computer vision and sensor fusion and deep learning and localization and path planning and control. And at the end of the whole program, we'll put you in teams, and you'll get to work with your team to build instances of these different tools, deep neural networks or controllers or localization filters, and actually put them on our self-driving car. You'll send them to us over the web, and we'll put them on the car, and we'll send you back videos and data of how your code drives the car, and you'll get a few go-arounds to see if you can get the car around our test track here in California.
Great. What is the technical interview like for a self-driving car engineer?
Yeah, it varies a lot. That's a great question. I've been through a number of them. You've probably been through a few of them.
Yep.
It can range in anything from kind of algorithms and data structures in C++. That's a very popular filter simply because autonomous vehicle engineering, or really any automotive engineering, occurs largely in C++, which is a language that a lot of engineers aren't familiar with, particularly a lot of web engineers, like I used to be, tend to be more familiar with languages like Python or Ruby or PHP. C++ is a compiled high-performance language that's a little bit different to work with. So that's one type of interview you might have. What types of interviews have you seen in the automotive world?
Agree, where you're either trying to, C++ is a big, like David said, is a big kind of like barrier, because they want to see, everything is done at one point in C++, because a self-driving car is really a series of big embedded systems. And embedded systems, work on the chip level, fast, power consumption, low power consumption, and so C++ is optimized for devices like that. I've done some interviews where you can choose your language, and so you're solving problems, and so being able to think algorithmically is very important. And I've actually done some where it's more on the interest side, more the behavioral side than it is the technical side, though they do always touch on the technical side. Know your languages, know your data structures, and then know how you would solve a problem. So if you're going to go into an interview for a path planning, have some experience with their course, hopefully, talking about, well, here's how I did the path planning. So right now we just finished our Bosch challenge, which was great. And it was this interview where it was a challenge where you would do a path planner, and at the end, if you were one of the top 25, you would get an interview with Bosch. And so we are still waiting to actually conduct those interviews. But ideally, the first question I can see coming from Bosch is, tell me about your path planner. Mm-hmm. And they're going to want to know about this. And so as you come from a Udacity course to one of our partners, the first question I can see coming from them is, tell me about your favorite project. And they're going to want you to talk about the favorite project. And even if you struggled with it, they're going to want to hear why you struggled with it, how you worked through those problems. Really, in the world of engineering, what they need you to be able to do is to solve problems. And so you develop, as an engineer, you develop kind of a toolkit that you can go to solve these problems. But the real value in you as an engineer is being able to solve problems and work through these problems. And they want to see that in how you think and how you figure problems out. So, did we send any mail regarding Slack channels, details, discussions, forums, links regarding any info for term 1? If not, where can I find those details? I don't know if Elizabeth actually sent that out or not, or if we do send that out. I do know that a lot of those details are in the classroom. So my assumption is that when you get into the classroom, you're going to see all that there. If not, expect something to be coming probably today, if you haven't seen that there.
Yeah, our community manager always sends out a handbook introducing you to the course. It's a digital handbook, but a PDF file that has the locations of all the different resources we've been running you through here, plus other resources. So check your email for that. It should be coming in the next day or two.
Right. I think we touched on this. Well, we touched on this a little bit, but David from Indianapolis said, my day job involves mostly Java development. Any suggestions on coping with constantly switching languages, like Java to Python /C++?
Suggestions? No, complain a lot. I complain a lot about how hard it is just to figure out the length of a string in different languages. To remember which language is len parentheses and which language is dot length. And,
yeah.
But I don't have any great suggestions for switching between languages other than just practicing a lot in the languages that you use most, so they're kind of like second nature. What do you think?
And we are going to try to make it a little bit easier. I guess we make it a little bit easier switching languages, that term 1 is all in Python, and then term 2 and 3 are going to be in C++. So we're not going to force you to switch between languages, but if your day job's making you use Java, can't help that. No. I did learn in Java, actually. That was going through a computer science program or computer engineering program. That was the first language we learned. I almost can't tell you anything in Java anymore because I haven't used it in so long. I guess the best way that I could think of to separate them in your mind is using different IDEs, so that when you get onto your computer, it visually looks different. You're in a different environment. You're working in a different way, and so that could help your mind kind of separate those different rules and different ways that you're typing different structures. So it's I guess the best suggestion I could have, or like David, complain a lot. Han from Michigan. We just finished term 1 and second term. Can we hold Oh wait, I think we already answered this one in the other channel, but yes, if you finish the other terms and you want to hold to a future date to start term 3, that's available to do. Atakan from New York City. Where else, other than autonomous vehicles, can I use the methods that I learned in this Nanodegree? We've kind of talked about that as well, that self-driving cars are really just a subset of robotics. And there's many, many applications of robotics, from drones to self-driving cars to pick-and-place robotic arms to tons of different things. But really, you can take these skills and use them across anything with robotics, or starting to get into the area of just AI if you wanted to get into software-based AI. So
really, you should just be a self-driving car engineer.
Much cooler.
Really no reason to want to do anything else.
Working through some of your questions that are coming through on the live chat. Can the training of the self-driving car happen in real time, or are we still bound to the traditional approach of gathering data and training after that? Real-time training is actually pretty hard to do. So you do need a special setup for that. I don't know if, well, I'll let David talk to more of the maybe you know some more of the technical aspects. I can say from the verification and validation side, one of the worries that you have if you're training on the fly is learning something that maybe you don't want to learn, or that's unsafe to learn, and immediately putting that into your ways that you react and control. So that is a concern on the more regulatory side. As far as the GPUs go and training, again, a lot of these systems are embedded systems, and embedded systems are not the best for training, but we do have some pretty powerful computers in certain, cars these days.
Yeah, it's a really good question. There are a whole class of machine learning algorithms that are called online learning algorithms, because just like the question you were asking, you're kind of learning online as you go, as opposed to saving the data and then offline later training a new model. That's not done a lot in autonomous vehicles for some of the reasons Anthony mentioned, and also just the fact that most people who are doing autonomous vehicle development are doing it on lots and lots of vehicles. And so if you have each vehicle learning something a little bit different, that leads to all sorts of consistency issues. Better to save the data, store it, merge it all later, and then train a model based on the entire data set. So all the cars, or at least whatever subset of the cars that you want, are running the same model.
Exactly. It's more like the group learning. You work better and you learn more as a group than you do as an individual, or at least you have a better collection of knowledge. So by merging all of this data versus just letting this car do its thing and this car do its thing, you get a better end result. I don't know if this is a question as much as a comment, but it is an interesting point to talk about. So somebody's mentioning how they live in India, and they joined the course really excited, and now it's illegal to have self-driving cars in India.
Shouldn't laugh, sorry. I guess the irony of the situation was funny, but it is not funny that self-driving cars are...
And so it makes, I guess with India, it makes maybe a little bit of sense from the way the government's looking at it. They're trying to protect jobs and everything. But I would imagine it's going to be, like somebody in here mentioned, it may be short-lived. India's going to want to keep up with the rest of the world's economy and the technology that we're coming out with. And eventually, I'm sure you'll see it trickle down over there. But again, I'm not the Indian government. I don't really know what they're going to do with it. But I don't see it being something that's going to be that way forever. And again, if you learn these skills, it's not like just because you've now got all these skills in self-driving as a self-driving car engineer that you're completely useless to the rest of the market if self-driving cars never came to your country. There's a lot that you can apply.
Yeah, there's a lot of automotive engineering in India.
Most
automotive manufacturers have very large campuses of engineers, and a lot of autonomous vehicle work is starting to be done there. I wrote a whole blog post about my thoughts on India outlawing self-driving cars, and in general, it would just surprise me if it lasted for that long, and hopefully it doesn't.
Agreed. Sorry, I'm going through some of the questions. Starting to come in a little quicker now, which is great. Do we have scope to read research papers and make better implementations of the projects? I know early on we allowed students to do basically the idea is if you meet the rubric, then go above and beyond and make it better. Absolutely. We definitely want to encourage you to be creative, implement it a certain way, but we do have a grading rubric out there. So we do have to make sure that our reviewers can grade that. So But anything you can do to go above and beyond, we definitely encourage, and we're really excited to see those projects, actually.
Yeah,
and if you do something that's really crazy and above and beyond, and for some reason that the reviewer, it doesn't make it through the review system, or you need somebody to take a little bit closer look, David and I are always available to get attention to that. Because we both just like looking at it anyways if it's really cool. What parts of the project, or what parts of programming a self-driving car will you not teach us? That's a great question. I'll let David maybe talk about some of the programming it, but we're also not going to teach you some of the things that don't involve programming. So how you make your car a self-driving car, how you wire it up, how you do the drive-by-wire system, configuring sensors, things like that. The hardware aspect of it, the integration aspect, we aren't touching on.
Yeah, I mean, the course is designed essentially to train you to work on autonomous vehicles for an employer. And so we've talked with over 30 employers about the curriculum and gotten their suggestions for what types of skills and knowledge they would like candidates to have when they come in for an interview. And so over the course of the Nanodegree program, you basically touch on each of the major areas that employers work on as part of autonomous vehicles. So deep learning and computer vision, sensor fusion, localization, path planning, control. And then you have opportunities to go deep in different areas related to autonomous vehicles in the elective portion. There are a few things that, for one reason or another, haven't made sense to cover. So one that I can think of off the top of my head is the CAN network. That's the actual network that the car uses to pass messages around in the vehicle. That's really almost more automotive engineering than autonomous vehicle engineering. We kind of go one layer up from that and assume there's an API you can use that will send messages like steering, throttle, and brake commands to the vehicle, which is often what you would encounter in working on an autonomous vehicle. And then, like Anthony said, a lot of the hardware aspects, both because those are hard to teach to people all over the world, and also because the goal of the course is not necessarily to help you hack your own vehicle and make it self-driving, but more to train you so that you can get hired as an autonomous vehicle engineer.
Great. Now, I've got a great question here, but I'm going to lead up to it a little bit. Some of you have kind of mentioned that you've seen some of our, or at least one of our other videos where David and I were, sitting there in a very casual setting, having a drink with each other and answering your questions. That's a little bit different from this, where that's just, there was a kind of an Ask Me Anything, very casual. We wanted to talk about everything self-driving cars. But obviously some people have seen that, and people are excited to start the course. And David, they hear you're going to Frankfurt next weekend, and they want to know if you're going to be able to grab a beer or whiskey with them.
Yes. I will be in Frankfurt for the auto show next week. I'm really excited. I've never been to Germany before. And we are having a dinner for students next Saturday night. So when you get into the Slack channel, poke around. I believe it's once you get into the Slack community, I believe there's a Germany, or actually I think it's a Europe channel. If you hop into the Europe channel and ask when the dinner will be for students on Saturday, I would love to meet you next Saturday, I guess a week from this Saturday, in Frankfurt. See you there.
Great. We've got a good question here is how many folks have successfully gotten a self-driving car engineer job with one of our hiring partners or through this program? Now, I will tell you that I can't give you an exact number, and we'll give it to you why. One, David and I know lots of people that have gotten jobs through this program. Two, it's also a little bit hard to track because if we get through one of our hiring partners, that's a little bit easier for us to get that feedback. But in addition to our hiring partners, our students have been in demand with people that or for companies that we haven't even talked to. And so when that happens, it's really hard to track that unless a student comes back and tells us. And we do have stories of that, and we have many students that are excited to tell us about the Udacity experience. But there's also ones that I think David and I have had to find out either through LinkedIn or other methods that a student hasn't normally just gotten back to our careers team. And so it's a really hard metric to identify. What we can say is that people are getting jobs before they even complete the program. So if you feel like you're ready, if you feel like you have the skill set, definitely apply for the jobs. You don't have to wait till the end. So before the program, people are getting jobs, and that we both can talk. We both know people personally that have gotten jobs through this program. So it's happening. It's just hard to actually track that numerical metric.
Yeah, that's actually one of the big problems at Udacity right now is we send out these surveys about who's gotten a job, and we get very low response rates on the surveys. And so we're looking at other ways to track whether people are getting jobs, because that's the ultimate goal of the program, and we want to be able to measure whether we're successful in that or not.
Agreed. So one thing you can do for us is if you get a job, let us know. Let us know through the surveys. Hit us up on Slack. We definitely want to do this, and we are excited to feature student stories, and we try to give students opportunities where we can let them showcase what they've done. Mm-hmm. So for robotics, so I'm also the product lead for our robotics program. I took somebody who is in our robotics program to our conference with us just to show off one of the devices he's been building on his own time using some of the skills he's learning in the robotics Nanodegree. So there's definitely great opportunities out there that we help you do, and that you'll find on your own if you go and you look into the space at all. Going through a few more questions. We've got a few minutes left, so if you have questions, definitely post them up here. Oktoberfest, people saying that you're going to be out there for Oktoberfest, maybe.
I wish. No, I'll be leaving in late September, unfortunately.
So we have a question talking about how do we look at our top students? Do we have a metric for rating our top students? Is that in the rubrics? How do these students differentiate themselves?
Yeah, so the main way students differentiate themselves is through the projects, and also through participation in our community as mentors and project reviewers. As you go through the Nanodegree program, you'll get opportunities to help out other students by either mentoring them or through our formal mentorship program, or being a project reviewer and helping review other students' projects. One of the things we do see occasionally from hiring partners is they would like to know, who are the top students in the program in a given area. And one of the things we're starting to do, although it's pretty early days at Udacity for this, is to run some of these hiring challenges, like the one Anthony was mentioning we did with Bosch, where we ask people to submit their projects to a leaderboard. And that's not something we require of you, but it's more just if you're interested in an interview with, say, a particular company or for a particular position, you can submit your project and we'll rank it and score it in some way, so that we can pull out candidates who might be particularly interesting in a certain situation. But in general, we're really more about imparting knowledge and trying to make sure that you have the knowledge you need to move forward in the Nanodegree program, and so it's really much more of a pass-fail situation than a ranking or competitive situation.
Right, and I think this is going to be the last question we're going to take today, and it's actually a good one. I don't think we've actually covered this one yet, which we probably should have. How demanding is this course?
How demanding is the course?
So if this person's a graduate student and it's going to be very heavily demanding on them as they're finishing their graduate degree.
Yeah, so I'll give the stats and then you can give your personal experience in the program. So the statistics on the course are that students that we survey report back spending an average of 17 hours per week on the program, but that is a very there's a very wide range around that average. And a lot depends both on how many hours you have to give to the program in a particular week. Some weeks may be a lot more than 17 hours and some may be a lot less. And how much knowledge you come into the program with. And also how far above and beyond you want to go in certain topics. We always have kind of challenge tasks that you can do with each project that you don't have to do to graduate, but if you're interested in pushing yourself extra far on a certain project, you can dig in even further. But 17 hours is kind of the number we put out there now, because that's what we've heard from students. But what was your experience?
Pretty much like that. It really varies on what you come into the program with. The computer vision pieces for me were easier because I had gone through computer vision courses and done some things with that. Neural networks were brand new to me. And setting up my GPU to program on them and use them for that type of training was new. And so there was a lot of weeks, and I was also working full-time and busy, and so there was weeks where I would spend a lot of time on it, and then there was weeks where I wouldn't spend as much time, and I would catch up and fluctuate. And so to me, I really like the soft deadlines, because I could do that kind of behavior. But I would say, yeah, you're looking anywhere from 10 at a very probably minimum of 10. With going up to maybe 20 is what I would say, but I would say 17 is a good average if you're looking at that. Yeah. And so But really, what my best recommendation for you is to start early, test it out, see what it takes you to kind of really get it, and then also, as you get to the second project, start early with getting your environment, either AWS or your personal laptop, figured out, because I struggled with that a little bit. And that will just help set you up for success. So start early, gauge your own time, and then go off of that. So
cool. It's a really fun program, or at least that's what we hear from students. We really enjoy it, and we hope you have a lot of fun too. We are so excited that you're going to be in the classroom with us. This is a really exciting time for self-driving cars, and we want to help you become part of it.
Yeah. Good luck, enjoy your experience, and we'll see you in the classroom.
Bye-bye.